Hey, IQ Kid here to talk about adding and subtracting rational expressions. A rational expression is a fraction in which the numerator and or denominator are polynomials. To add and subtract rational expressions, the denominators must be equivalent. Sometimes they aren't. So to make it where you can add and subtract rational expressions that don't have equivalent denominators, you have to find the LCD, which is the lowest or the least common denominator. And I'm going to show you how to do that in a couple examples. So let's start with the first example. In this first example, let's work with the two expressions 3 over x squared, or the expression 3 over x squared minus 1 plus 4 over x squared minus 4x plus 3. Okay, so step 1 with this is to factor it. So I'm going to go ahead and factor it. So 3 over x minus 1 times x plus 1 plus 4 over x minus 3 times x minus 1. Okay, so in the second step, we take the 3 over x minus 1 times x plus 1 plus 4 over x minus 3 times x minus 1, and we notice that there's a like term, so we don't need to account for that like term when we multiply. So we're going to do x plus 1, x plus 1, alright, x minus 3 over x minus 3 times 3 over x minus 1 times x plus 1 plus 4 over x minus 3 times x minus 1 times x plus 1 over x plus 1. So you're taking the two terms that are not like terms, and you're multiplying them to the other fraction. That way you can get a common denominator. So now if you notice, all three of these are in the denominator for both fractions. So let's do step 2 now. Step 3. Okay, so in step 3, we are going to simplify. So let's take the x minus 3 times 3 over x minus 3 times x minus 1 times x plus 1 plus 4 times x plus 1 over x plus 1 times x minus 3 times x minus 1. And let's simplify that. So we get 3x minus 9 over x minus 3 times x minus 1 times x plus 1 plus 4x plus 4 over the same. So x minus 3 times x plus 1 times x minus 1. And then next we are going to add or subtract the functions, the expressions, the fractions in step 4. So we're going to take the 3x minus 9 over x minus 3 times x minus 1 times x plus 1 and add the 4x plus 4 to that, and we will get 7x minus 5 over x minus 3 times x minus 1 times x plus 1. Now some teachers will accept the denominator still factored out as your final answer. So this next step is optional and really dependent upon the teacher. So in the next step, you're going to expand or FOIL the denominator. So in this step, we have the 7x minus 5 over x minus 3 times x minus 1 times x plus 1. And we're going to multiply that out and get a 7x minus 5 over x cubed minus 3x squared minus x plus 3. So this is your final answer if your teacher requires you to FOIL the denominator or expand the denominator. Okay, so let's do another example. In this example, we're doing the exact same thing. We're going to simplify by subtracting 5 over 12n plus 3 from 7. So to start, let's factor the denominators, which in this case is actually not possible. We're just going to have 7 over 1, which is the same as 7, minus 5 over 12n plus 30. So it's exactly the same. So step 2 is to find the least common denominator by multiplying the unlike terms just as before. So 7 over 1 minus 5 over 12n plus 30. So 12n plus 30 is really the unlike term. So 12n plus 30 over 12n plus 30. And you can write times 1 over 1 just to show that there's no unlike terms going from there to under the 7. So in step 3, we are going to simplify. So we have 12n plus 30 times 7 over 12n plus 30 times 1 minus 5 times 1 over 12n plus 30 times 1. Okay, so we get 84n plus 210 over 12n plus 30 minus 5 over 12n plus 30. So now we're ready to add or subtract the two fractions. Okay, so we have 84n plus 210 over 12n plus 30 minus 5 over 12n plus 30. So that is going to be 84n, because you're just subtracting the numerator, plus 205 over 12n plus 30. And this is your final answer, and it cannot be expanded. So step 5, expansion, or expanding slash foiling, is unnecessary. It is not needed. Okay, anyways, so yeah, that's how you add and subtract rational expressions. Thanks for watching. I hope this helped. Yeah, have a great day.